How's it going?
How are you guys?
Pretty good. Is Britain just the cutest?
I
He's
know.
so great.
So nice.
I wish I had I have a daughter, but she's in Hawaii. I don't know how they'd ever meet.
I know, that's why I'm like, I should set you, my niece, she's the cutest girl ever, and she's out there at BYU, Idaho right now. And I'm like, oh my goodness, she's a freshman, but she's going on dates like crazy because she's ready to go on a mission, and so she's just this fun, good girl who everyone's like, oh, you're really awesome, and I want to hang out with you. And so I'm like, oh, he should go out with her because he's so nice.
We're talking about you, Britain.
Oh, he's on. Oh, how great. Hi, Britt.
Hey guys, how are you?
Good.
We were talking about how cute you are. You're so nice.
Oh, thanks.
It's like you're the kind that I want my daughter to marry.
Look,
Oh, it froze.
Yeah, it froze
Yeah.
up.
Say that
She's,
again. Maggie.
mine froze up. None of you froze up.
Okay, say that again. You said something cute. I could tell.
No, I was just saying he probably feels so awkward from all these compliments from all these women. So.
no, it's fine.
Hold on. I gotta go get a crying baby.
Okay.
So, how did the homework go for you guys? Or the prep stuff?
Good.
Yeah, not bad for this lesson. It's kind of, I can't believe I'm saying that.
No, it's good.
Yeah.
Great.
It's pretty similar to what we've been doing, I guess, so not bad.
Yeah. Hi, Ashton. So your sheet, Britton, was really great, and I don't know how to do anything like that on the computer. Like, so how you did that the last time for the first test, you even did your study guide that looked awesome,
Oh.
and you just did that sheet for Jenny. That's really good.
Yeah.
Well, it's easy. Do you have something on your computer called the snipping tool?
Not that I know of. I've never heard of that.
Cool.
So that's what?
Snipping tool?
Wow.
I don't know if they have it on a Mac or not, but
No.
if you just search it, it lets you like copy an image that's on your screen, and then you can just put it in Paint and like edit it or whatever, and then just paste it in a Word document.
Huh.
Wow. I trust you.
Is that how you get all the little symbols?
Yeah, usually.
That's so
Because it's
great.
pretty quick, because then you don't have to write everything out, and then you just
Yeah.
paste it in there. So it's easy.
Yeah. That's nice.
Yep, it's been awesome. Okay.
So, anybody have any questions about the preparation assignment?
Yeah, let me see.
I feel like I did.
I think I did too. Okay, go ahead if you, I'm trying to find mine still.
I think that mine was actually in the homework, but
Okay.
I guess it kind of, I guess my view of QQ plots, like, I don't know, there was one question, and actually I think the one in the prep assignment, like, I would have called those not normal distribution just because they're so, like, they may not be, like, crazy wavy, but they're still kind of wavy.
Well, that's what
Yeah.
I was just doing the homework, and that very first one on the homework was the elderly men and women and the young men and young women. I just finished doing the QQ plots, and I was like, two of them, I'm like, okay, those are normal, and the other two, I'm like, there's no way that that is normally distributed. And I looked at the answers, and they're like, yes, this meets the requirements. I'm like, what?
Yeah, those
Yeah.
top two, they're like, woo, like super wavy.
Yeah. I
Yeah.
don't get that.
It's
Yeah, it was confusing.
Did you do the homework already, Britton?
No, but I mean, it seems like every time I look at a QQ plot, like even if they're barely like S-shaped or outside. I
Yeah.
don't really know how to decide.
Yeah. It was that way. I noticed it on the preparation one too. It wasn't as extreme though as that homework one.
Yeah, that
Is it
homework
pretty
one
bad
is
on the
like
homework?
crazy.
Yeah, like there's no way that that's normally distributed. I mean, it was like
Did they
I
say
guess
it was
what?
like abnormal but like close enough to?
No.
No?
That's
Yeah,
what
it
was
doesn't
so
make sense.
weird. And so then I looked, I'm like, well, maybe there was like a high sample, and like they're all small samples.
Yeah,
Oh,
there's
really?
like 8,
So
9.
Yeah.
I
Well, and
I
that
just
doesn't
hope
even
they don't
work in
test
this
us on
case.
something like
Will we
that.
ever have to answer it's abnormal, I wonder? You just assume they're all normal?
I hope.
That's what I'm hoping
Oh,
for.
you know on the test that's the one that's gonna be in the test.
Oh yeah,
They have an abnormal one and we say, oh well, it's normal.
Yeah.
But when we were doing Q plots, like for the most part, I mean, I would get the right answers for all of them. And so now that we're
Yeah.
into this other stuff, it's the opposite. Like I'm not doing well. So it's kind of frustrating because I have no confidence now with my knowledge of QQ plots.
Yeah,
Yeah, for sure.
I don't know.
that's where I'm at.
Well, and speaking of, okay, so like on the prep, under B as in boy, so like the answer under the plots that they have, the explanation right before the letter C, so it says the variances for each group are equal. 299.186 is not 4 times that other number.
Oh.
Isn't it 2 times? What's with the 4 times?
Oh, because if it's it just tells you if it's if they're normally distributed or not. So if it's less than 4 times greater than the lowest variance, then you can assume that it's normally distributed. But if it's more than 4 times greater,
Yeah.
then you know that it's abnormally distributed.
Okay. So the 4 times is the thing that tripped me up because in number 3, it's 2 times. Like, I thought the rule was if it's, because I even like took all the variances from each example, to find the high and the low, and then like the directions, even in the book, it says if it's 2 times is big. But is this a rule? The 4 times?
Yeah.
Yeah.
Okay, so the rule is 4 times.
Yeah, there must have been a typo in the book or something.
Yeah.
So Jenny, I watched that video, and you must have watched the video because in that video he does this whole diagram of the largest standard deviation, and then he does the smallest, and he does 2 times the smallest.
Yes, that's exactly right. And I took notes on that, so I'm like, okay, it's 2 times. So are they wrong in that video then, Natalie?
Well, that's what because I remember reading in the book it said 4 times. So then when I saw that video and it said 2 times, then I just kind of put in my head 2 times. But then when Britton just said it needs to be 4 times, I'm like, oh yeah, that's what I originally read. I think maybe there's a typo.
Okay, yeah, it's not only a typo. Oh, it was in the video. You're absolutely right because I just saw my notes. Says I watched the videos for the prep, and he said he drew like a big S for standard deviation on the board, and then he did the bigger than sign, and then he said 2 times your smallest.
Well, standard deviation, isn't it?
Oh,
so maybe I need to be reminded what variance is. What is variance?
The square of the standard, the square of the standard deviation.
Okay.
So
I would go with the book, but
yeah,
I don't know. That's something we could ask her, I guess.
Yeah.
So, because that was one of my questions, and then when I went and watched that, I decided to watch that video because that was my question: was what is the variance? Because I didn't know exactly like what to test on what is the bigger, what's supposed to be 4 times bigger than the other one. So I watched that video, and then he did his diagram, and he's getting the numbers from the standard deviation.
He did.
Is that right? Is that what you guys are getting your numbers from?
Just because he did.
So
well, you use it.
No, I got it from the variance on the chart. Variance. It says variance.
Yeah, you can use the standard deviation to find the variance, but
That's just more work.
yeah.
Yes.
In SPSS, when you go to make the QQ plots,
Yeah.
it comes up with a like table of descriptives for each group or whatever.
Yes.
Variance is one of the things that's on there.
Yes. That's where
Oh, okay.
So I got it from the variance. So I did it. I did like the steps, and then he said, if it's 2 times as big, and he literally, like he takes the number. He's all 3 times 2 is 6. Is it bigger? No. Like, but should he have been saying 4 times?
Well, but if you even noticed though, Jenny, on that one, he said that incorrectly. He did because at the end he said oh, is 5 greater than, and he wrote 2 times 2, and he said 5 is not greater than 2. Well, 2 times 2 is 4. So either way, it was supposed to be that it's greater than 4, but he said it's greater than 2. So my point was is that I noticed that mistake. So I very well could have made another mistake.
Okay. Well, that's really
Yeah,
good.
I just ignore it.
Yeah.
Yeah.
Isn't that super? Where I'm trying to like find every avenue, and then I write notes on what they give us, and then it's wrong.
Yeah. That's really frustrating.
That is super frustrating. Okay, so so is that how you, Tori, you're doing it, is when you do your QQ plots, you look at this graph that says the variance, and then you go from there?
Yeah.
And they're descriptives.
Okay. So then you just go and you find of the 4, if there's 4 different categories, which one is the smallest.
And then which one's the biggest?
And then you multiply the smallest by 4 and see if it's bigger or smaller than.
Yeah.
Okay. Okay, so then I'm going to ignore him. That's so annoying.
I wonder if he's like if the variance is the square or the standard deviation squared. I wonder if he was doing something like
Yeah, like some backdoor thing.
shortcut type thing. I don't know, but not using.
I went when he was explaining it. I went and I looked at my descriptives to see, and I saw he got all of his numbers from the standard deviation, and he took the smallest standard deviation and he just multiplied it by 2, and then he took the largest standard deviation and he compared it to that. I mean, it was super simple.
Yeah.
Well, I wonder if that is some kind of shortcut, because if we get the variance from the standard deviation. But the thing that throws me off is if he's multiplying it by 2, the variance is this it's squared, so that's it times itself, right?
Yeah,
Like-
it seemed to be.
Yeah, that's it times itself, and that's different than times 2.
So, yeah. But I don't know if that's just some kind of.
Anyway, well, I just didn't know how to find it the other way. I wasn't clicking with that, so I'll just find it this way.
So you said he multiplied it by 2
He did.
and then compared it to the highest?
Right.
Yes.
Well, because if we look at number 3, for example, if we were to do that to get the answer for C on number 4, we would get it wrong.
Oh. Then yeah,
Well,
just.
let's see. Yeah, I think so.
Well, no, because actually those are the numbers that I think he used. Is that 13.052? Is that what you're saying?
Uh-huh.
So,
Well, because let's see, if we multiply it, and that comes up to 26, which is greater than 17, but
that was the exact example he used, Britton.
It is.
really,
Yeah.
And so he said that it was, since it was greater than, then you knew that,
that it was normal.
yeah. And then he said, but let's pretend that, and then he switched the numbers. No, because he said if the largest one is greater than, he says it fails the test. It says the largest standard deviation has to be smaller than the smallest one times 2 for the assumption.
Okay, yeah, so that would make sense for the answer for C.
Right.
So maybe that is just a quick way.
Oh.
But
Wow.
I would just play it safe and just do the
Descriptive.
so you don't so you don't get confused
Yeah.
using the variance. That's what I'm gonna do.
Okay.
Yeah, I'm gonna do that too.
And while we're on that one, so on G where it says present your conclusions in the form of English, so it says we have sufficient evidence. Will you tell me like what the evidence is that I'm looking at? Like we have sufficient evidence to say at least one of the mean ages of death is different from the rest. Where
So that the English sentence, that's the H one, right?
G. Oh well, I'm sorry. On the prep, it's G.
Yeah, it is H.
On mine it says H.
Oh, lesson 14.
Yeah. It
Prep.
could have been combined with G where you reject the null.
Oh yeah.
But yeah, so what you're looking at pretty much is the p-value
Okay.
compared to the, what the heck is it called?
This level of significance.
Thank you. And so the p-value is what gives us our sufficient evidence. So if it's lower than the level of significance, then we have enough evidence to tell us that the null hypothesis is not correct.
Okay.
I don't know if that makes any sense at all.
It does, because really, so the sufficient evidence is found in the p-value.
P-value compared to the alpha.
Okay.
Uh-huh.
Compared.
Yep, because we're always, the null hypothesis is always what we're technically assuming to be right.
Yes.
And so there's either sufficient evidence to suggest that it's not correct or sufficient evidence to suggest that it is correct. Or not sufficient evidence.
Not sufficient evidence. Okay. Okay. Great. I just had to hear it a different way one more time.
No worries.
Okay. So.
I'm not a huge fan of like the number 5 where it says take action. Like, what do you do now?
Yeah.
Oh.
I don't either.
Ugh,
It just seems like it's kind of subjective to whatever you want to.
Yeah, I agree. Jenny, are there any other
Doesn't it
ones
say
that?
that?
Oh, go ahead.
Yeah, not on the prep.
okay.
Oh. Yeah, not on the prep. Thank you. I'm good.
What were you saying, Britton? Sorry.
Oh, never mind. It was. I don't even remember actually.
Sorry.
It wasn't important though.
So do you guys want to go for the quiz then?
Yeah, let's do it.
Sure.
Group meeting, lesson 14. Knowing my luck, I would open the Unit 2 exam.
Oh my goodness. That would be awful.
Probably not open, so you probably say.
Oh, good. See, they did that for me. Okay.
All right, let's start this.
In an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different from the others. True or false?
True.
Sorry, I had to switch things, so I haven't
Oh,
opened.
sorry.
That's okay. Sorry.
When you're ready. And then I'll go on to the next one.
Okay, I'm there. Sorry.
Okay, so for the first one, in an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different from the others. Not true.
Because that's the whole thing, isn't it? We're trying to find at least one that it's different.
Yeah.
Right.
Okay.
Number 4, what requirements need to be checked when performing an ANOVA hypothesis test? Sample means are all positive. Data in each group are normally distributed. Variances are equal in each group. None of the above, or B and C. The data needs to be normally distributed. That's for sure.
And the variances should be equal.
Okay, so B and C.
So they're trying to trick us up on the sample means are all positive.
There is something I want to find.
It's the F distribution. The values of F are never negative.
Yes.
But-
Okay.
Yeah. So the data are normally distributed in each group, and the variances are equal for each group.
B
Okay. Um, 5. To check if each group is normally distributed, do the following. Construct a scatter plot, construct a histogram, or construct a QQ plot for each group. Uh-oh.
Did you guys
Oh,
put
QQ?
So,
Yeah.
yeah.
That's what they seem to be wanting us to do now.
And then on 4 we put B and C, right?
Yes.
Yeah.
Okay.
You
We
can't.
assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample size, or each group has the same sample size.
It's the second one, right?
Let's do the second one.
Yeah, just
Yep.
variance less than 4 times the smallest.
Yep.
Yep.
Oh.
Okay.
If it's the third one, you're going to be mad.
Yeah, right? Me too.
But dude, that's talking though about sample mean. I don't.
Yeah, it's talking about sample mean, so
Yeah,
it's
that's
not
about
even the
sample
same.
mean, and he was talking about standard deviation, so it wouldn't be right anyway.
Yeah, okay.
All right. Number 7. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between each pair of samples. If there are 3 samples, there are 3 pairs, 1 and 2, 1 and 3, and 2 and 3. How many pairs are there when there are 4 samples?
Write this down.
1 and 4, 2 and 4, 4 and 4. If there's
1, 2, 1, 3.
Would there be 6?
Hold on. I
There's-
need.
I think there's 9, but let's see.
So 1, 2, 1.
Yeah, 6 would make sense, actually.
The reason why I said 6 is because you've already got all 3 of those covered right there, and then you just need to make sure you do 1, like 1 and 4, 2 and 4, 3 and 4. So that's 3 more you're adding to what we already have.
Yep. 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4.
I'm guessing. But
Yeah, I would guess 6. Is that what you said?
that's it. That's what I said, but I don't know if that's right.
I think it's probably right.
That's what I get too, because there's no need to repeat, like
Yeah.
you said, like 4 and 1.
Right.
So that's what I would say.
I think that's an educated guess.
Okay.
Well educated guess.
So
Okay.
Okay.
Sorry, what, Jenny?
I was going to say, so you guys read that question as a whole, not separate. If there's 3 samples, that's what you do. I was reading it as like, if you're doing a hypothesis test, how many pairs are there when there's 4 samples?
Yeah.
If there's 4 samples and there's 2 pairs, wouldn't it be 8? No.
So, here, let me. So I wrote it out just so I could see
Is
it.
it from our textbook?
No, I haven't seen this in our textbook. I didn't write it out. I can write it out so I can see it.
Here, well, I wrote it out. So, I don't know if you can see.
Okay, yeah.
Um,
It's blurry. Okay.
So,
1, 2.
I have to see.
It has to be. I wrote it out. It has to be 6.
Yeah, so like I went down with 1 and did 1, 2, 1, 3, 1, 4, and then when you go to do 2, you don't need to have 2, 1 again. So then you just add 2, 3, and 2, 4. And then when you do 3, 3 is already paired with 1 up here and 2 right here. So you don't need to do 1 and 2 again. So then it's 3 and 4. Does that make sense?
Yep, now it does. Seeing it visually.
Yeah.
Thank you. Thank
Yeah,
you.
no problem. Okay. So 6. Okay, so number 8. The soccer shoes data has 6 groups: A, B, C, D, E, and socks. These data can be found in the wiki. Load all 6 samples into the quantitative inference procedure spreadsheet or perform an ANOVA test in SPSS and observe that the p-value is 0.0809. Remove the socks data. What is the p-value? Okay.
Well,
All
So-
right. We have to open up the box.
and it's already, I think they already did that auto
Yeah,
thing. So
recode.
should we just like remove the socks right now?
What do you mean?
Well, like delete the data for it.
Oops.
Sorry, I'm not following you, Britton.
Can't open it because I have no idea what we're looking at.
Well, let's see. So
There's footwear, kicking, accuracy.
Hold on, my computer takes forever to open these things up.
So what are you going to, Britton?
well, I'm just confused by the question, I guess. So it says to do an ANOVA test and observe the p-value and then remove the socks data. And the only way I can think to do that is to go back to the like first page in SPSS and just delete the socks data. But
Yeah, that's the only way like, how else would you remove it?
yeah, I don't know. I'll do the regular ANOVA test first and then
see
go
that it's
back.
the 0.081 p-value, right?
Wait
Because
a
that's what we
second.
have to determine first.
When you guys bring up the ANOVA test, what options do you have?
Yeah, I only have the one option.
That's all I have too, is kicking accuracy.
So
Footwear.
that's why then I just went and tried to do the descriptive statistics and see if I could do the explore,
Mm-hmm.
and then I had more options there, but it doesn't.
Wait, what do you only have one option for?
The kicking accuracy.
Oh,
Is that the same? Do you have more?
yeah, no, that's all I have too, but
You have footwear, right? Footwear and then accuracy. That's
No, I just have kicking accuracy. Do you have something besides that?
Oh, I guess I just had the footwear categories like the A.
Oh,
Like
I
when
mean,
you bring up the ANOVA test,
yeah, once you bring up the ANOVA test.
Okay. Sorry. Let's see.
I'm going to try opening
Well,
the Excel
wonder if
file
you
for
have
it in
to-
SPSS and see if it's different.
Okay.
I wonder if you have to do the automatic recode anyway.
But they're all recoded, it looks like. But
Yeah, they are.
they're not like separated. They're all in a row.
Well, they're not, they're all assigned a letter instead of a number. Is that what?
Maybe we could try it. On this lesson, I didn't do any automatic recodes for any of them. Did you?
Yeah, I didn't either.
I don't remember.
Here, I'm going to try it and just see
Now
what
I
happens.
did. Now I
Oh,
changed
yeah,
it,
yeah.
but now
It's a good idea, I think.
To go ahead and
I
do the.
recoded it. Now let me just make sure. So the dependent list goes into, or the kicking accuracy goes into the first one, right? I always get confused on this one. So like,
Yeah, I
The
would.
dependent one is yes.
That,
Because
yeah,
it's
kicking
dependent
accuracy
on the
would go there.
software.
Did you recode the footwear? Is that what you recoded?
Yeah, and I
Yeah.
just went through and deleted Well, I guess I should probably try deleting the socks. I had just deleted like the numbers in the socks.
Oh, yeah.
Here, I'm gonna go through and delete the rest of them.
So what was the value that we were supposed to have for P?
It was the point 0.0809.
Okay, yeah.
So you got it?
Yep. So I'm going to go delete the socks now.
Okay, wait, hold on. So how did you get it? Because I don't even know how to. I'm not there.
Okay, so did you do the auto recode?
Did
So
you
I just went to the auto recode, and you did the footwear? So you did footwear code.
Yeah, footwear code.
Did
and
you
then add new name? Sorry, what's that, Jenny?
Yeah, what did you rename it?
Just footwear code.
Code.
And then you did add new name, and then did you just hit OK?
And you hit OK.
Because that's what I had done.
And
Okay.
And you're oh.
So then you just go to analyze, compare means, one way ANOVA.
Analyze.
Oh, and then you just did it. Okay, right after.
Yeah, and then the kicking accuracy is dependent on the footwear, so you put the kicking accuracy on the top, footwear code on the bottom, and then we hit options and select descriptive and means plots.
Okay.
Continue, okay.
And then that's where you get all the descriptives.
Yeah, and then it's just our sig.
Okay, Britton, did you delete the socks?
I'm going to do that right now.
So, and it was point.
I have a number. I want to see if it's.
So then you went back to the original and you deleted all the socks, right?
Yeah.
Yep. Then you just do another one-way ANOVA, right?
Oh, let's not do that. That's yuck.
Okay.
So I got 0.309.
Yeah, that's what I've got too.
Okay. Hey, bugaboo.
For the p-value, 0.309.
Yep.
That's what I got.
How are you doing, Jenny?
I'll figure it out. It's I guess I don't understand there's like no help in the book or anything to figure out how to do this report summaries. You guys are deleting stuff and
Yeah, because the question asks or tells us to delete the socks.
Oh, it tells us to. Okay, I need to read it.
Yeah. So then you just go to the original screen that like has all the numbers and stuff, and you delete all the socks things. So the numbers and then the category or whatever.
Okay.
And then you just do the same thing without the socks stuff in it.
Yeah. Do you want us to talk you through it right now?
No, let's
It's
just.
time, Jenny.
Yeah, let's do it.
It really is
Jenny.
fine.
Let's
We
talk you
probably
through
should
it.
just do it now.
Yeah,
It'll
let's
be
talk-
better. Okay. Let's see. So where are you at right now?
Sorry.
Just get. Why don't we just start from the beginning?
Let's
So
see.
pull.
Yeah, soccer shoes up.
Yep.
Yeah.
Okay, and you had said you saw the original things. So did you already perform the automatic recode?
No. So to do that, let's see. It's okay. So you go under transform.
Yep.
Okay. And then I put footwear over
Yep.
in variable, and then let's see. Okay.
And then you just pick a new name for it.
So in the book, they recommend using the same name and then just doing code afterwards.
Okay.
Yeah.
We
As
all
long as it's something you can recognize, it'll work. So.
Yeah. Okay. And then so it gave me some output, but there's there's nothing. Like it says, oh, like I didn't see any. It says alter type. Am I supposed to do? You know what I mean? Like, so from that list, I got an output box and.
Okay, you can just ignore that for now.
Okay.
And so if you go back to the other page, now you're going to see another column on your data that says footwear code on the right side, and that just shows you that it
Go back.
recoded everything correctly. So it gave A number 1, B number 2.
Okay.
Is that what you're seeing on there?
Yeah. Okay. So like transform auto recode, and then I put that over there, and I don't hit OK. I gave it a new name.
Uh-huh.
You
Then
will
you hit OK.
I do hit OK. Okay.
Yeah. And then
What comes up?
it brings up an output page, right?
Yes.
Okay, so then you should be able to, on the SPSS icon at the bottom, if you click on it, it'll bring up that you have 2 pages still.
Oh.
So one says output 1, and the other should say soccershoes.sab. Do you see either of those two?
No. Like on the.
On the bottom of your computer, you know how you would like hit to go to Internet Explorer or Chrome or something like that, or your Word documents.
Okay.
That's where the SPSS symbol at the bottom, where you would click that.
Oh, okay. Gosh, I have like 3 open, so I just pick one.
Yeah. So pick one and click on it until you see the 2 files that are showing. The output and the soccer shoes.
Okay. Okay. How did? Oh no, this is Women's Poet. I'll try to open up the right one. Sorry. Let's see.
You're fine.
Yeah, no problem.
Or if it's still on your screen, you can, if it's not covered, you can just click on to go back to the original data. You want to just, what we're asking you to do is to get back to that original data.
Okay.
Yeah.
So where you see footwear accuracy comments and then the footwear code.
Okay. You guys can't screen share, can you?
I don't think I can on this.
I can't. I think Tori can, but do you want to just open up the do you have the soccer shoes that the files we're looking at?
Who are you asking?
I was thinking something else. I was asking Jenny, but
Oh, okay.
Okay, so variable view. Okay, data view, variable view. I have like soccer shoes.
.sab.
Did I what?
Does it say soccershoes.sab and then data set like 5 or something, or 1?
1.
Yeah, that one is the one you want.
Okay, and so I did that transform.
Yeah. So are you seeing a page that says footwear accuracy comments and then footwear code?
Yes.
Okay, perfect. So that's what the auto recode did, is it just made that new column on the right.
Okay.
So it assigns like footwear category A number 1, category B and number 2.
Yeah.
Okay. So now we're ready to go ahead and do the other comparison.
Okay.
And do you remember where to go for that one?
I would go into the analyze. Just is this the descriptive data? Or
Almost.
No? Compare me.
Compare means. Yep.
And then you do the one white Nova.
Yeah, because there's more than 2 groups that we're comparing.
Okay. So I have kicking accuracy and footwear code.
Uh-huh.
So depend list, put the kicking accuracy.
Uh-huh.
Okay. footwear code and factor.
Yep.
Or-
And then if you want, you can also hit options.
Yeah. Do the
And hit-
descriptive.
Yeah. And the means plot. That'll just give us more information, so it'll be more simple later.
Okay.
And then just hit OK.
Yeah, continue and then okay.
Okay.
Yeah.
All right, guys. I got it. Okay. Good.
So that shows how, with like all 6 groups, and then if we want to delete the socks group, we just go back to that other page, the soccerstatistics.sav, and you scroll down to where it says socks, and you just are going to highlight that data and just delete it.
Oh, you can literally do that?
Uh-huh. So let's do that really quick too.
So B is socks, and you just go. Do I just highlight on the B's?
On
No,
the S.
No,
Oh.
It's at the very bottom.
go to the bottom where it says socks.
Oh, socks. Oh, gotcha. Okay. Oh my gosh. Okay. And do you just highlight socks or all the numbers and stuff?
I highlighted socks and all the numbers.
Yeah.
Did you
Yep,
delete?
I just do all 4 columns, like footwear accuracy comments and
And
footwear code, just down to the very bottom.
Okay, I'm deleting.
Okay.
I highlighted it, push delete,
Perfect.
and then I need to do it again because.
So then does your table end with 100 E33 and then code 5?
Why it okay, so I hold it down. Sorry, this is how lame I am. I'm highlighting the first socks, I'm going over, and I go all the way down, so it's a big blue box of socks, and
Yep.
I press delete and it only does that one bottom box.
That's what happened when I did it too. So I had to go through and delete each thing individually.
Oh, that's a bummer.
Yeah.
Annoying.
What
That
you can do too is just use the arrow keys and hit delete,
Yeah, that makes
and it
it.
goes pretty quick.
that is crazy.
That's annoying, but
Oh my heavens. Oh, that's just ridiculous. But you guys were able to delete the whole thing?
I was, but Tori
I
wasn't.
was.
Yeah, I can't. I just tried again, and yeah, it's still. I have to use the arrows to delete it all.
That is terrible. I'm so
Mother, Jenny, do you have a Mac?
I do.
Do Brittany?
That-
I don't.
I don't either.
Yeah, I wonder if it's
Mac thing.
because we have a Mac. Mac's letting us down.
They are. I'm sorry, you guys. Okay.
Oh,
you're
you're fine.
Oh, so many socks. Couple more. Okay. Now they're gone.
Okay, so now we're just going to compare these 5 groups instead of the 6.
Okay, so going to analyze, compare, and OneNova again.
Yep.
And now I just have in the dependent list kicking accuracy and factor footwear code.
Right.
Yep.
Okay, and then okay.
Yep.
Okay, and you have to get rid of all the socks. Like it can't just stay on the left side. Like I didn't bring it into anywhere. Like, do we have to delete it? Do you
No,
know?
because you already deleted it.
Yeah.
So it just pulled from the 5 groups that were left on that other page.
Okay.
I don't know
Oh,
if that.
and it told us to. Never mind. Okay, it told us we had to.
Yeah, only
Right.
if it tells us to.
Okay.
So now,
And so
did
then
you
it wants-
see the p-value?
I sure do, and I see it as 0.309.
Perfect.
Yep. You got it.
Thank you.
Good job.
You're welcome.
Tears of joy now. That's awesome. Okay.
Okay,
9.
perfect. Okay, the p-value always goes up when only one group is removed compared to the p-value when all the 6 samples are included. True or false?
That's false compared to what we just did, right? I mean, true compared to what we just did.
Wait.
No, wait. Oh, yeah,
Always
yeah.
goes up, but then it's talking about the other. It doesn't make sense.
Sorry, say that one more time, Britton.
Oh, it's worded really weird. Saying that it always goes up when one group is removed.
I mean, I don't know, but it went up from when we
Yeah.
removed one group.
I know, like, does it always, though? Yeah.
Yeah, and if it's just referring to this scenario, or
But we've never
I
done
would
this
just-
before.
I would just say true, just because we don't really know. But
Yeah.
That's what I would say. It's true.
well, let's see. Didn't the p-value go down?
No, it went up because it was 0.0809.
And now it's 0.3.
Oh yeah.
Yeah.
You're right.
Okay, so good guess. What is the highest p-value you see when removing only one group? This is like what? You will need to compute an ANOVA for each possible option. What? Like,
We have to
I don't
check
know.
all
do we like remove?
Do we have to remove everything until we're doing 2 and 2 and 2? Like, I don't get it.
I don't either. Why are they doing this to us?
It's annoying. We didn't do anything like this in preparation for this.
Yeah.
Okay.
exam week 2, mind you.
For each possible option, that's gonna be like
Oh,
6.
okay, so I think we need to go through and just how we deleted the socks. We're going to have to do it and delete one by one by one.
Yeah. Like, yeah, but
We'll still have
keep
5 each
substituting
time.
it back in, yeah. Wow, that is really
Are they
That's tedious.
serious right now? What is the highest p-value you see when removing only one group? That's what we just gave for number 8. We removed only one group. Oops, sorry,
Yeah.
baby.
It wants us to remove each group, though.
You'll need to compute an ANOVA for each possible option.
Are they kidding? Like, that's so dumb. Okay.
I'm almost tempted to just
What'd you say, Britton?
no, I'm almost tempted to just put down something and move on.
Yeah, I would be okay with that.
But then, yeah, it says number 11. When all 6 samples are used, what's the minimum? So, do we have that information to?
Oh. No, we'll have to.
Oh my gosh!
So they're making us delete it all and then put it all back in.
What?
Yeah.
For a test?
Gosh.
Well, maybe you should see if Britton and I get the same answers because you guys have to delete it one by one, and that's super annoying. I mean,
Yeah.
you're welcome to, but
So,
I hate that.
are you guys going through and deleting like E next, and then?
I just did A first.
But you're writing down the p-value before it's gone, before you take it out, right?
Uh-huh.
Well, we already know it.
I know the whole thing.
Oh.
So we've got to auto recode everything.
I know. I just
Okay.
deleted and before I auto recoded. I'm like, ah.
Whoops. That's okay. You're okay. That was a good tumble.
I can still
Alright.
auto recode though. I think I can without even after having deleted.
Yeah, you should be able to. So don't worry about that. So what did you delete?
I deleted A.
Okay.
Hi. This is the most annoying question so far. Like, of
Well-
all the trick questions.
They do not teach you this well.
No.
They don't give you the information.
So it's 0.060 after removing A.
Yep,
You got the same thing?
I did.
So now I have to close down that
Me too. It
and
won't let
open
me
it up.
paste it back in.
Yeah, okay.
Oh my gosh.
Do you guys want to write these down? Maybe.
Yeah.
Okay.
Yeah, so
So
what did
without
you
A,
say?
it's 0.060.
0.06.
Without B.
Without A.
Oh, without A.
So is that without socks too, or is that just?
That's
No,
with
that's
socks.
with socks.
Well, then that's confusing. So then that would mean 9 was wrong. We would want to put false because the p-value went down,
So
right?
it doesn't always.
So it doesn't always. That's the tricky part.
Yeah.
Okay, so
So
we'll
9
change
is now
that.
false.
Because it went, yeah, you're right. It went down to 0.06 from 0.08.
Yeah, I don't know why they didn't ask that before,
After,
like
right.
after we did this
Right?
part.
I know. That's a little bit sketchy.
And,
I guess it's to see if you're paying attention.
Right?
Yeah.
and it's annoying that like 11 and 12 they give to us after we've like deleted everything. Like,
Yeah.
you know,
Oh,
those about. Maybe I'll just start over and compute that stuff for those two.
Okay, so without B, I get
you get 0.052.
point. Yeah. Yep.
Okay. I just got that also.
And that's just without B and with everything else, right?
Yes.
That's
correct.
Uh-huh.
Oh my Lanta.
Hey, I say that. That's funny.
Yeah?
Yeah. Not very many people say that. Well, I haven't said it in a long time, but I used to say it constantly.
That's funny.
Oh, my Lanta.
Okay.
I
Okay. Did you get 0.081?
I took a little bit longer. Sorry.
Oh, you're fine.
Opening it up, I was fumbling. So.
This is without C, Britain.
Without C.
Yeah.
All right. I got.
You got
What did you get?
0.081.
Yeah, I must have done this. I had to have messed it up because
Well,
that doesn't make
see
sense.
if I mean, I could have done something wrong too.
No, it says 0.448, and so I doubt that that's right. Although I guess.
Wait. No. You're good. I didn't delete the right thing, I guess. So ignore that.
Okay, so 0.448. Do you want me to do it again?
No, I trust you on that. Or, I mean, I can do it really quick, but I'm right.
That's fine.
Yeah, 0.448.
Okay.
Yep, sorry.
No worries.
so without C is 0.448.
Yeah.
Right. Okay, for removing D, I got .031.
Okay. Sorry, mine's taking forever.
No worries.
Oh my goodness.
Yep, that's what I got.
Hey, you're all right. Yes. Here. Look at this stuff. Ooh.
Watch us not, like, really have to do this.
Well, it says
I don't know what else we would do.
No, I don't know what else we would have to do. I just think it would be really funny if, like, someone were like, oh, all you do is this. And we're like,
Yeah.
Like, oh, are you serious?
I wish that person was me, and I wish I was right.
Okay. Good thing is this is the last one, because we already did the socks.
yeah. So I got .50 for removing E.
Oh my goodness.
Yeah, you're way faster than I am, so we'll just go with that, because we've been the same.
Okay, what'd you put?
.050.
Okay.
And then without socks, it was .309. So
Yep.
So the one, let's see.
ISP value.
The highest one was without C. It was 0.448.
No, it was just .448.
Yeah.
Oh, you said
0.448.
Yeah.
You're awesome, Tori.
I had to think about it. I was like, wait.
All I
Okay.
heard was a 0 in there, and I was like, oh no, because all the other ones are .0, and I'm like, that was the one that was different.
Yeah.
You guys are so patient with me.
0.448. Okay, and I'm sorry. My soccer thing just barely. I've literally closed and opened and closed and opened like 5 times.
No worries.
Oh, you're good.
So we just write 0.448 for the answer for number 10.
Yeah.
Yeah.
Maybe it's okay.
When all 6 samples are used, what is the minimum smallest variance?
That is what I am pulling up right now.
So that should
Yeah,
that should be when we remove. Oh, the variance.
Oh.
Yeah.
So actually, I wonder if I have all of that though in my output. If I scroll down, I should.
Well, let's see. You deleted one of the groups, though, right?
Okay, so now.
Except I don't know, when I see this output, I don't know where the variance is. That's my problem every time.
Yeah, I don't know where it is either. I think we have to
I think you have to go into the
do
QQ
it separately. Yeah, I think so.
Yeah.
And we have to make those ways, so.
Do I have to go back and redo all of that again, removing them and doing QQ plot?
Yeah.
Oh, wow.
Wait,
This
is
is a
that
happy day, guys.
What?
no? Wait, what are you saying?
So I have to go back, I think, and redo all of those, removing one, because it says when all 6. Oh wait.
No,
No,
when
when
all.
all 6 samples are used. Okay.
Yeah.
Okay. Oh, that's much better.
Okay, so now somebody help me.
Okay.
So we do, when we go in to do the QQ plots, is the dependent list the kicking accuracy, and then the factor is the footwear code?
I think so.
Okay.
I have it written. Where? Okay. I have to
Okay.
remind myself where I go for the QQ plots. It's analyze descriptive data. Oh yeah, that's where I'm going.
And then it's
Oh,
plot.
but we have to recode. Man, that whole recode thing.
Okay, wait, but you go, for descriptives, you'd go to explore, right?
Yeah.
Okay. Do you do anything?
Then,
Oh,
and then on
plot.
display, you click plots. and then on the right side you pick plots again, and they're normality plots with tests.
Yeah. Okay.
I'm still here. I'm just reading the graphs that I'm pulling up. I'm just
Fine.
trying
Okay.
to find.
Okay, so Britton, does anybody have that thing up?
So I just now did the I don't.
Yes.
So the highest one
So
that
look,
I'm getting is for D.
where do you find that at?
So
Is it in the graphs, like, or not the graphs, the charts
no.
that say like test of normality?
So you go up. Let's see. Okay, no. So it's the one right above that.
Case processing summary?
Um,
Are you looking at descriptive?
no, the one under descriptives.
So do you have the variance
Yeah.
as 27.358?
For the first one. But if you scroll down, so we have to look at the variance for each thing, each group. And so group D has, oh wait, but we're looking for the smallest one. Well, for 12, it's asking for the largest, and that's group D. And then for the smallest,
Wait, where does it say this?
On the descriptives, it lists. Did you get to the descriptives yet?
Well, I did the QQ plots.
So you don't have to do a QQ plot. So that's where you go to the analyze and the
Descriptives, and then
descriptives,
okay.
and then the explore.
Okay. Yeah.
And the column you're looking at is the.
And then you hit statistics instead of plots.
No, you hit plots.
no, so it does make QQ plots. They're just further down.
Yeah.
Scroll up. So Britton, you the first you said test of normality. It's in between the test of normality and the case processing summary. That big
Chunk.
oh, here, I'll screen share.
Okay, let me pull it.
Okay. Do you see it now?
Yeah.
So like there's case processing summary, but we're looking here under descriptives.
Okay, yeah, I didn't get that. So maybe
Oh, okay. So,
let's see.
Hey, Tori.
yes.
I just wanted to check with you. I wrote down all 6
Oh,
of them.
now I've got it.
Okay.
I changed something in the options, so it's fine.
Do you have C as the smallest, Tori? And D as the largest?
Yes. I didn't write them down, but
So like the smallest is 27.208 and the largest is 53.158?
yeah.
Okay. Holy cow. I guess this is a statistics class, huh?
Okay, so the smallest one, what does that say?
21.208.
And then the biggest, 53.
0.158
Okay,
Yeah.
so now one more time. 11.
is 27.208 and 12 was 53.158. So then that's when, for 13, we have to go and look at the QQ plots.
No, for 13, that's the test for equal variances.
Oh, when we multiply.
Between these two.
That's,
Yeah, so it passes it, right?
Yeah, it passes that part.
because you would do, just so I know, you would do the 27.208 times 4, right?
Yeah.
And that's clearly above the 53.
Yeah.
So you know it passes it.
And then, what do you need, honey? Hold on, I'm gonna go grab her pacifier, guys. Just a second.
No worries. Oh, okay, so now it wants us to construct the QQ plot.
Yeah.
And I think,
Now for the tricky part. See if they're
I know. I'm just going to have to say yes. Let me go. So it should have done a QQ plot, right? I'm going to go.
Yeah, so we should already have those. I didn't end it right. So I'll just scroll down, and then you guys can see what mine look like.
There are some that are pretty normal, but a couple that are like S-shaped.
So obviously I didn't do I don't have the QQ plots. I should have had it by doing that, though.
I feel like for the most part, these look normal. This is the only one that like looks sketchy. Is
third one?
This one for B. That's kind of
Yeah.
And then there's a little bit here, but not enough to.
Yeah.
Okay, so construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Well, I just want to say true, even if that one is a little off, because I feel like they were.
Yeah, I would say true.
Yeah, in the videos there's an example of that, and you said even though there's these on the side, you know, out of it, it's basically.
Okay.
I'm wondering why I don't have QQ plots. So did you do anything else to do that?
Yeah, how did you get?
Well, what you can do is select both in that screen.
Oh.
I just selected plots.
Plots?
Yeah, and so that's why I didn't get it the first time, I think, with the statistics. So then I tried it with both, and it brought them both up.
What do you mean both, though?
So if you go into Analyze, Descriptive Statistics, and then Explore,
Right?
down at the bottom for Display, it says both statistics and plot.
I have both. That's what's so weird.
Oh, yeah, that is
Go to
weird.
Plots, maybe.
And I went to
And you
plot.
have normality selected, right?
Yep.
Okay.
Did you keep scrolling? Because you have to scroll through a lot of stuff to get to it.
Yeah, I was scrolling like crazy. I just tried to do it again. We'll see. Because I've done this before. This is how I did it for.
Baby, that hurts.
Let's see. So it doesn't do it when. Oh, okay. There. I finally got it.
Okay.
Okay, sorry. Thank you. I just wanted to make sure I could get to it and was doing it right for when I have to do it on my own.
Yeah, no.
Yeah. Okay, so we're going to assume it's true.
Yeah.
And then 15, the test statistic for an ANOVA hypothesis test is an F statistic if the p-value is the p-value the area to the right or the left of the S statistic.
Should always be
right.
I think.
The right?
That's
Well,
what I think. Isn't that correct?
The F doesn't have to be.
I think it
It
always
should
has
be.
to be to the right.
yeah, because it's right skewed.
Yeah.
Yeah, it says a p-value for ANOVA test is the area in the right tail. We'll never divide the area in the tail. So right.
Yeah.
Okay. Well.
Okay, guys, we're good.
You're kidding me. You got. I mean, I'm yay, but that was a lot of work to get all that for you.
Yeah.
Oh. That one
That
where
was
you
a
had
long
to
one.
delete them all, that was just dumb.
Really dumb.
Well, good job.
Yeah.
Yay.
All right, thanks for putting up with me today. So Thursday it's 9:30.
Yeah, so just 30 minutes earlier. And Britton, we'll just hold off on like talking about stuff until you get there.
Yeah, you're fine. Usually my class gets out maybe like 9:25, so I'll probably be on pretty close to 9:30 anyway.
Okay,
So it should be fine.
cool.
Have any of you guys done anything for that yet? Like started studying or done
No.
prep work?
No, I haven't yet.
I've looked over the exam review, you know.
I haven't yet. I'm kind of in denial that I have to do that this week.
Right?
Yeah.
I'll probably start working on it tonight, hopefully. We'll see. I say that now, but
Yeah, I'm gonna try, but we'll see how it goes.
I'm gonna start right now. So
Oh, Jenny, you're so good.
thank you. You guys are awesome. You have no idea. I I hope you do have an idea. But
Yeah.
Okay.
All right.
Cool.
Thanks, guys.
thank
See
you.
you guys Thursday.
See ya.
Bye.
Great.
Austin.
Bye.
Bye.
Bye, sweetie.